Assalamualaikum warahmatullahi wabarakatuh. My name is Nurhaisa Najra binti Abdul Halim with metric numbers AE170045.
Hello, my name is Muhammad Haziq Nakiuddin bin Ismail. My metric number is CE170016.
Hello, my name is Azhari bin Sabsul Kamal. My metric number is AE170027.
Hi and Assalamualaikum. My name is Nafisa binti Zulkifli. My metric number is AE170085 and I will explain about the parity check and LRC.
Assalamualaikum and hi, my name is Fatih Izzati binti Fahmi Rizal. My metric number is AE170051.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurhaisa Najra binti Abdul Halim. So as a starter, I will discuss the introduction for error detection and correction technique. So in digital systems, analog signals are transformed into the form of bits. Usually if there is any changes occur in the position bit, it will lead to a significant error in the data output. Errors can be found in most of electronic devices, and this problem is solved by using error detection and correction techniques to get the right information data. So next is error. Input data can be affected by external noise or other physical defects during data transmission. Thus, the input data is not the same as the output data obtained. Although the data changes just one bit, it may affect the entire performance of the system. It is what is called as error. As the data transfer will be in the form of bits, the data error is likely to change positions between 0 and 1. As shown in the figure 1.1, it is the input data that corrupted during the data transmission by the external noise. Next is types of error. Here are a few errors that may occur in the system network during data transmission. The first one is single bit data error. This error type rarely occurs in a serial communication system and appears only in a parallel communication system. It is called a single bit data error since only one bit changes occur. Next one is multiple bit data error. It is called a multiple bit error since the changes occur in two or more bits. This error can occur in both serial and parallel data communication networks. And the last type of error is burst error. It is called a burst error since the changes occur in a set of bits. The burst error is calculated from the first bit of change to the last bit of change. From figure 1.4, the error is third bit to 6th bit. All numbers between the third and 6th bits are also considered to be an error. This set of bits is called as burst error. However, this type of error in a serial communication system is challenging to solve compared to the other error. Next one is error detection. In a digital communication system, errors are transmitted from one communication system to another along with the data. If the errors are not corrected quickly, the data will be lost. To detect the errors that occur in the system, some redundancy codes are used to detect it. The redundancy will be added to the data while it is transmitted from the source. Here are the types of error detection. Parity checking, cyclic redundancy check, longitudinal redundancy check, and checksum. These types of error detection will be discussed further by the next members.
So, what is parity check? I bet all of us familiar with this word cause it often repeated on digital electronic and computer network. It is a concept to detect the errors detection and its elimination is a vast field in electronics. In electronics, we want the signal to transmit as at the receiver end. We want to avoid any distorted signal at the receiver. So parity check is one of the method to detect the errors, but parity check is only for detection single bit error.
Hi, my name is Fatin. Right now, I want to explain more about the cyclic redundant check, or known as CRC. As Najwa stated in the introduction, there are 4 types of method to detect an error in the communication system or channel, and CRC is one of them. The CRC can detect the errors in the communication channel by the binary vision. The error can be detected in the remainder of the polynomial division. Next, we go to the CRC generator. In the CRC generator, an algebraic polynomial is presented as bit pattern. Based on this example, consider the CRC generator is x power 7 plus x power 6 plus x power 4 plus x power 3 plus x plus 1. Based on this figure shown, this is how we got the binary bit. Thus, for the CRC generator, the corresponding binary pattern is 110 110 11. Next, the properties of CRC generator. There are 2 different types of rules in the generator CRC properties. First one, it should not be divisible by x, and the second one is should be divisible by x plus 1. Next, we go to the steps involved to get the error or to check the error. First, we calculation of CRC at the sender side. In this step, we will get the CRC reminder. Next, the second step, appending CRC to the data unit. The third step, transmission to receiver. And the fourth step, checking at receiver side. After we done all the steps, we can check whether there is any error or not. There are 2 steps that we got from the step that we did. First one, the result might be remainder 0 or the remainder not equal to 0. If the remainder is equal to 0, that means there are no error detection and the system is accepted. But if the remainder is not equal to 0, that means there are any error during the transmission and need to be retransmission again. So this is how we can detect the error by the CRC. Thank you.
Alright, the next one is longitudinal redundancy check, LRC. LRC, also known as 2D parity check. Data that the user want to sense is arranged into tables of row and column. In this method, a block of the bits is divided into table or matrix of rows and columns. A redundant bit is added to the whole block to detect an error, and this block is transmitted to the receiver. The receiver uses this redundant row to detect the errors. After checking the data for the errors, the receiver accepts the data and discards the bits of redundant row. Alright, the next one is performance of LRC. LRC increases the likelihood of detection of burst error. But if 2 bits in one data unit are damaged, and 2 bits in precisely the same position in another data unit are also damaged, the LRC checker will not detect an error.
Hello, my name is Azhari. I would like to talk the last part in error detection, which is internet checksum. In internet checksum, the data of each of the M bits is divided into K segments. At the end of the sender segment, the data will be added using first complement and sent along with the data segment. While at the end of the receiver segment, all the bit data will be added by first complement. If the outcome is 0, then the data obtained will be accepted, otherwise it will be rejected. Next, I would like to talk about error correction technique. There is two methods for error correction technique, which is forward error correction and backward error correction. In forward error correction, there is three methods. First one is Hamming distance, next is using XOR, and the last one is chunk interleaving. In Hamming distance, minimum Hamming distance is d minimum equal to 2t plus 1. Lots of redundant bits need to be sent with the data. Next is when using XOR, a packet is divided into n chunks, and then the exclusive OR of all the chunks is created and n plus 1 chunks are sent. If any chunk is lost or corrupted, it can be recreated at the receiver side. The last part is chunk interleaving. Each data packet is divided into chunks. The data is then created chunk by chunk horizontally, but the chunks are combined into packets vertically. Each packet sent carries a chunk from several original packets. In backward error correction technique, it is dependent on a number of protocols and algorithms. Transmitting device will send data to a receiving device. The receiving device will then run checks to ensure that all of the information is present, readable, and makes sense. If the received information does not make sense, the receiving device will send a request to the transmitting device to resend that data.
Assalamualaikum and hi, my name is Muhammad Haziq Nakiuddin bin Ismail, and I will show you the simulation of capturing Wi-Fi frame using the Wireshark Network Analyzer. As I click this, it will start to capture the Wi-Fi frame. This is the top panel. This top panel is the monitor capture frame. So it will capture all type of protocol such as TCP, ARP, MDNS, and all other protocol. Then to stop capturing the frame, you can select this red icon and we can start to analyze the protocol. So the standard of internet protocol is using the IPv4 that has a unique IP address. So this middle panel is where you can analyze the frame of the protocol. So first, let's take a look at the TCP traffic. TCP is Transmission Control Protocol, and it has a source port of 27021 and destination port of 51832. And next, let's take a look at MDNS protocol, that is multicast domain name. So it has its own unique transaction ID, and this protocol has a length of 118 and UDP load of 110 bytes. And lastly, I will show you how to capture the DHCP traffic. So we start again to capture the traffic. by clicking on this fin icon and then open the command prompt and type ipconfig renew. Wait for about 1 second and then type ipconfig release and wait again, and lastly you can type ipconfig renew. Wait for about 2 seconds and close the command prompt and stop capturing the frame. Then we search for the DHCP protocol, and this is the DHCP, and you can analyze. It has a source port of 68 and destination port of 67, and the length is 324. So it has a UDP payload of 316 bytes. This DHCP request has its own transaction ID. Same for the ACK and the DHCP for release. So that's all from me. Thank you.